All right, so today we will be looking at this equation, 4 cosine squared of x minus 1 in the interval 0 to 2 pi, and I'll just make this a little larger here. All right, so our main goal here is to try to isolate the trigonometric part of this equation. So in our case, I want cosine of x equaling to something. It is often the case, though, that you need to use some algebra before you get to that point. And using algebra with these types of problems often means factoring or using some other method. So we take a look at 4 cosine squared x minus 1. We can actually factor that. That is a difference of squares. That has the form of a squared minus b squared, which factors as a minus b times a plus b. So what's a here? A would be 2 cosine x, and b would be 1, because if you square a squared, you get 4 cosine squared of x, and if you squared b, you get 1. So we would have 4 cosine squared of x minus 1 factoring out as 2 cosine x minus 1, 2 cosine of x plus 1. So if that's equal to 0, then it's equivalent to having this equal to 0. And by what we call the zero product property, you will have solutions when either of these equals 0. And as I said in the beginning, my goal here is to isolate the trigonometric part of the equation, which we're doing. And by the way, I put these parentheses around the cosine of x, and please forgive me, I was supposed to have them on here as well. So really, you have one here, have one there, and around there. So when we solve these equations, cosine x equal 1/2, I'm going to look at the unit circle and ask myself, where is cosine equal to 1/2? Well, that's in quadrants 1 and 4. And our solutions would be, when is cosine equal to 1/2 in quadrant 1? That's pi over 3. And how about in quadrant 4? 5 pi over 3. And for the other equation, cosine of x equals negative 1/2. That's in quadrant 2 and quadrant 3. And our solutions there would be 5 pi over 6. Sorry, 2 pi over 3. And 4 pi over 3. In total, those are all our solutions. Right, so we look for as many solutions in the interval that's given, which is 0 to 2 pi. And yeah, for our final answer, we would probably just list these out. Pi over 3, 2 pi over 3, 4 pi over 3, and finally 5 pi over 3. Right, thank you very much.